later. And the first thing we're going to look at is what happens when you put a square root around any function. You've already done some square root graphs, the square root of x. And there's a picture of the square root of x. Straightforward. Okay? No problem. And you did transformations with the square root of x. No problem. Okay? So for example, if you wanted to graph the square root of x plus 4 using your transformations unit, you would move your square root graph 4 units to the left. No problem. But if you had to graph the square root of x squared plus 4, we don't know how to do that yet. So what we're going to do is we're going to analyze the inside function and the square root function to find out how they're the same. So this is a new technique for graphing square root of x plus 4. In the old technique, you had the square root of x, you moved it 4 to the left. That's still a great technique. If you had that graph, that's what I would probably expect you to do. But a new technique would be to graph the inside function first, which is x plus 4, and then notice a couple of things. If I graph x plus 4, notice what happens to the x-intercept. It stays the same. Because the x-intercept is where y is 0, right? And what's the square root of 0? Still 0. What other number can you square root that stays the same? Like square root of 9 is 3. It doesn't stay the same. Square root of 0 is 0. It stays the same. Square root of 1. So another thing you would notice is on your red graph, you have the point -3, 1. Both of those points are also on the square root of x plus 4. So one of the strategies we're going to use for graphing square root functions is find out where it's equal to 0, where the original function is equal to 0, and where the original function is equal to 1, and plot those points. If you find other points that are easy to square root, for example, there my y value is 4. What's the square root of 4? 2. Notice you have that point on your blue graph. So looking at your original graph, taking some points that you know how to square root, taking 0 and 1, because they stay the same, you'll be able to get an idea of what the square root graph looks like. Notice that square root of 4, which is 2, would you agree that 2 is less than 4? Okay, yeah. If I picked another number like 9, what's the square root of 9? 3. 3 is less than 9. So for most of your square root graph, in particular this section here, can you see that the blue graph is underneath or less than the red graph? But there's a special situation between 0 and 1. Have you ever checked this out? What is the square root of 0.25? 0.5, which is bigger. 0.5 is bigger than 0.25. So between 0 and 1, when you square root a number, the answer is bigger than what you started with. Right? Square root of 0.81. 0.9. It's bigger than 0.81. So what we have is on the next page, we have a summary. So I'm going to skip this page temporarily. Oh, no, I'm not going to skip. Here is the summary, and these will be the key things that we're going to do. Number 1. I just like highlighting. 0 and 1 on the graph of the inside function will stay 0 and 1. We call those invariant points. So that's the first thing you're going to look at. You're going to graph the inside function and find out, are there any points that are 0 and 1? Those stay the same. Number 2. Where the graph lies between 0 and 1, the square root graph will be above. So maybe between 0 and 1, square root of f of x above f of x. Number 3, above 1, the square root graph is below the original graph. And finally, the fourth thing we're going to look at, which where the graph lies below the x-axis, the graph of the square root does not exist. Maybe you can't square root a negative. So let's look back at these 4 key characteristics and see if they showed up in our first example, and we'll look at a second example as well. There's the blue one is my square root graph. The red one is the graph of the function inside. Are the points 0 and 1 the same? Yes. When the y values are between 0 and 1, my blue graph is slightly above my red graph. That's characteristic number 2. When my y values are bigger than 1, my blue graph is below my red graph. That's true. And when my y values are negative, notice that the line keeps going here and the y values are negative. My square root graph doesn't exist for those points. So let's look at a second example. And this is an example that if you use transformations, people often get it wrong. What's the mistake people do here? They move this one 2 to the left, but it's actually moved 2 to the right. Why? It's not in factored form. So if you were graphing this using transformations, you would first have to factor this out and write it like that. It would be a reflection over the y-axis and then move 2 to the right. Can you see that that blue graph matches up with those transformations? It's been reflected over the y-axis and moved 2 to the right. Now, if you use the new technique would say graph the inside. Negative x plus 2. Well, that has a y-intercept of 2 and a slope of negative 1. That's my red line. Do I have points where it's equal to 0 and 1? Yes, those points stay the same. Step 2, any points where the y values are between 0 and 1, my blue graph is slightly above my red graph. True. Any points when the y values are bigger than 1, my blue graph is below my red graph. True. Any place where the red graph is negative, my blue graph doesn't exist. True. So we can use this new technique not only to graph square roots that we already knew, because you already know how to graph these square roots, but to graph new square root values as well. So some of the questions that we get, they just give you a graph. They don't even give you the equation. They say, here's the graph. Can you graph the square root? So you would go through the 4 characteristics. You would say, are there any values that are equal to 0 and 1? Well, here the y value is 0. Here the y value is 1. You might even go through and say, are there any other y values that I know the square root of easily? Like I know the square root of 4. I know the square root of 9. Sure enough, Here we have 4. The square root of 4 will be 2. You could add that point if you would like. Characteristic number 2, between 0 and 1. When your y values are between 0 and 1, your square root graph is going to be slightly above. Okay? You have to be careful here, because if you over-exaggerate it, it's going to be bad. I mean, that's really over-exaggerating. But can you see that this went back in time? That's not allowed. That's a bad idea. So even if you're a little bit back in time, that might lose a half a mark. Sometimes it's very hard to show it slightly above in that little bit of space. And then, characteristic number 3. Whenever your y values are bigger than 1, your square root graph is below. And don't draw anything where your original function was negative, because you can't square root a negative number. So then, for our blue graph, the domain is x is bigger than or equal to negative 2, and our range, y, is bigger than or equal to 0. Part B. Again, mark where it's 0, mark where it's 1. This one, nothing shows up that's really nice values to figure out. Between 0 and 1, it will be slightly above, then below. Domain, x is less than or equal to 6. The range, y is bigger than or equal to 0. It is, unless they add more transformations to this. Like I could put a negative out in front of that square root, which would be a reflection over the x-axis, then it wouldn't be. But if you just have a square root graph, okay, then, and your original, sometimes you get functions too that never, we're going to get parabolas that never go to 0. That's going to have an effect on the graph as well. So no, it's not always greater than or equal to 0. Okay, question for practice is number 5.